Hi everybody, it's Mr. Long here. Yet another screencast on factoring. Specifically today on this screencast, we're going to look at difference of squares, but we're going to have exponents of 4 to do our difference of squares. I could have 6, I could have 8, as long as they're even, or actually as long as it has that pattern of x squared and a constant. Okay, so we know that the pattern for difference of squares is a squared minus b squared is a minus b, a plus b. That's been that way since grade 10. So let's look at a specific question that we're going to work through. So here it is right here. Solve by factoring. 2x to the fifth minus 2,592x equals 0. Same thing as always. We common factor first. Always common factor. So what's a common factor here? Well, that's an even number, 2. 2,592 is an even number. Looks like to me 2 is a common factor. I have x to the fifth and x. That means x is a common factor. So I'm going to remove 2x from each of those terms by division, okay? So 2x to the fifth divided by 2x is going to give us x to the fourth. X to the fifth divided by x is x to the fourth. 2 divided by 2 is 1. 2,592 divided by 2 is 1,296. And again, that still equals 0. So now I've got x to the fourth minus 1296. Same thing as last time. I've got x to the fourth. I don't want x to the fourth. I don't typically complete squares with x to the fourth. It's a lot easier to complete squares if I use x or something like u squared. So how do I convert x to the fourth to u squared? Well, I would have to set u equal to x squared in order to get u squared equals x to the fourth. Okay, so I'm going to end up with, now I do that substitution. Oh, by the way, there's going to be an x-intercept at x equals 0 because of that common factor. That's just a little note there. And it's right here. So now let's take a look at our factoring. So I end up with u squared minus 1,296 equals 0. Now, do I need factoring to solve that? No, but this is, I'm teaching you how to factor. And you'll end up with the square root of 1296 is 36. So you do that with your calculator. And then we end up with u minus 36, u plus 36, right? Because we have our a squared minus b squared is a minus b, a plus b. And then I set out to solve. Well, what do I need to do if I'm solving? Well, I know that in the first bracket, u minus 36, u is going to equal 36. If I set that factor or bracket equals 0, u plus 36, u is going to equal negative 36. Now replace u with what it originally was, which was x squared. So here I have x squared equals 36, which gives me plus and minus 6. Here I've got x squared equals negative 36. There's no solutions for that, DNE. Okay, so, and again, what am I trying to do always? I'm trying to change x to the fourth to u squared. Well, if x to the fourth is u squared, then x will always be, x squared will always be u. Okay, so now let's go ahead and try and do some graphing. So I know the x-intercepts for this one were 0 and plus and minus 6. So let's go over here to the graph and see what it's going to look like. So their y-intercept is clearly 0, which is also the x-intercept. And it's x, so it's a single x-intercept. And those two are singles as well at negative 6. Oh, look at that. Maybe I need to learn where my negatives are on the graph. There's a classic Mr. Long move. So that should be plus 6 and that should be negative 6. And we know the end behavior. The end behavior is x to the fifth. Well, x to the fifth has the same end behavior as x and x cubed. So it's going to start down low and it's going to end up high. Okay, and these are all single x-intercepts. We're going to cross there, and cross there. And that's our graph, folks. Let's try another one. So again, these are factoring with difference of squares. Well, my hair is looking good today, as per usual. Okay, so let's do this one. Solve 625 minus 16 times x minus 1 to the fourth equals 0 by factoring. So we look at this, I see a subtraction sign. 625 I recognize as maybe being a square number. It is. It's 25 squared. 16, that's a square number. 4 times 4. I've got exponent fourth. Well, if I'm working with fours, I can also get square root of 4 is 2. So, I can do my substitution and do this. So here's the thing. I want this to ultimately look like this. I'd like that 16x minus 1 to the fourth right here. I would want that to look like 16u squared, right? That's ultimately what I want it to look like, to make it look like a quadratic. So in other words, I'm going to have to set u equal to x minus 1 squared. Okay, so and I can do that over here, and I can show you this. So what I end up with is, so x minus 1 to the fourth, I want ultimately to be u squared. So that means this part inside the bracket must be u squared, because remember that anything to the fourth means it's squared again, right? So that's going to be my u value, is x minus 1 squared. This is a little different and a little more challenging substitution. So we do that. Then I just have, it comes nicely into this now. 625 minus 16u squared. Square root of 625 is 25. Square root of 16 is 4. Square root of u squared is u. 25 minus 4u, 25 plus 4u equals 0. And then I solve. So I set each factor equal to 0, solve for u, and then I have to remember that it's actually not u I'm looking for, it's x minus 1 squared. So now what I'm going to do is bring this down to here. So if you notice, the first one I'm going to have is x minus 1 squared is negative 25 over 4. Well, I can't square root a negative, so there's no solutions there. Then when we go over to this one, it looks just like the regular quadratics that we've solved with completing the square, right? So I'm going to square root both sides and add 1. Here's the inverse operations. So I end up with 1 plus or minus 5 over 2. Okay, 1 plus or minus 5 over 2. The two answers end up being negative 1.5 and 3.5. So then I can go over to here and I can do some graphing if I want. I know that the y-intercept is 625. The negative there in front of the x term will mean it's opening down. Okay, so I've got a graph that will look just like this. Something like that. Now the vertex probably will be over here a little bit, right? And it'll be more boxy because the vertex is going to be in the middle of those two values. So, and again, more boxy, and then come down. Okay, the y-intercept is 625. So the vertex would actually be higher than 625. Okay, and that's that, folks. So again, pause, rewind, go over these videos to help you. But that's the whole idea of completing the square when you have x to the fourth, or you could have x to the sixth, etc. Have a good day.